From almost 3.7 billion miles away at the frozen edge of the solar system, turn a telescope back the way you came. You won't find cities or roads or a single human light. What you'll find is a pale dot, half lit, a few pixels across. And from those few pixels, you could prove with zero doubt that this world has oceans, a living atmosphere, and something working non-stop to keep it alive. That dot is home. From out there, Earth is the most obviously alien, most obviously inhabited planet in the whole sky. And since we've decided to tell you absolutely everything on this one, you better get comfy and enjoy this monster of a video in peace. You with us? Then let's get going. Let's start by setting the pieces on the board. Pluto sits crouched almost 3.7 billion miles away from us. Though, truth be told, with its very eccentric orbit, it's a little closer right now, around 3.1 billion miles. And now you'll tell me, yeah, 3.7 billion miles, just another number. Nope. Hear me out. Picture having to drive there in your own car, holding a steady 80 miles per hour flat out toward deep space. Never stopping. Not for gas, not for the bathroom, not to sleep. You know how long it'd take you? Something like 5,000 years. 5,000. Let's just say that for the next school trip, you might want to pick somewhere else. That's exactly why when Clyde Tombaugh discovered Pluto in 1930, he didn't see a single mountain, valley, or crater. He saw a dot. One measly white dot creeping slowly across the constellation Gemini. And things didn't get better in a hurry, you know? Even in the 1990s with the Hubble Space Telescope, back then the absolute peak of technology, Pluto was still a blurry, grayish little ball that looked badly drawn. We had to wait until 2015 and the New Horizons probe screaming past at full speed to find out that faded dot was hiding mountains of ice and a vast plain shaped like a heart. Right, so now let's flip everything around. Picture yourselves up there among the ices of Pluto, sitting around clueless, trying to figure out how to track down good old Earth, the planet you came from. How would you do it? First attempt, you go looking with the naked eye, and here I'll stop you right away, because there's a geometric catch. If you look for it on the dark side of the sky, you'll never find it. And you know why? Because the inner planets ride orbits that hug the sun, while you, out on Pluto, are circling on a giant, completely external orbit. So, from where you stand, an inner planet is always glued to the sun. Never lets go of it for a second. Hey Curious Squad, before moving on, answering the question, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up, so you don't miss out on our daily videos. Astronomers have a fancy word for how far a planet can wander from the sun as it loops around. They call it maximum elongation. And for Earth seen from Pluto, you know how big that wandering is? A trifle. 1.5 degrees. To picture it, take 3 full moons, line them up side by side, and that's the most Earth can ever stray from the sun, period. And watch out, because that little geometric fact has a wild consequence. Earth, seen from Pluto, has phases. That's right, just like our moon, just like Venus, when it swings closest to us, it turns its back, shows us its fully dark face, and poof, gone. New Earth, invisible. When it's on the far side of the sun, it'd be a beautiful full Earth, except it's plastered right behind the sun, completely hidden. The only decent moment to catch it is that brief window of maximum elongation, when we see it lit halfway, a perfect half Earth, like a sliver of moon. Okay, so setting aside the problems we'll get to in a minute, Earth seen from Pluto would actually be visible to the naked eye, because it'd shine at a magnitude of about 4.1, roughly 6 times brighter than the faintest star you can see by eye, and about 7 times fainter than the North Star Polaris. And you'd even be able to make out our moon at magnitude 6.4, right on the ragged edge of what a human eye can grab without instruments. But there's a but this big. The supervillain of this whole story is him, the sun. Because seen from Pluto, the disk we're so used to back on Earth shrinks down to something tiny, almost a pinprick, like a star. Except a star that, distance and all, still blazes about 300 times brighter than our full moon. It's like having a cop's flashlight aimed straight into your eyes from about 3 feet away. A monstrous glare that wipes out everything around it, Earth included, if the flashlight is the sun. To switch off that beacon, you need a special scientific gadget, the coronagraph, a kind of ultra-precise optical mask you slot into the telescope to hide the solar disk. Without a coronagraph, Earth and the Moon stay invisible to the naked eye, drowned in the sun's light. We've got to level up. Say you Plutonians grow up to be professional scientists and get to use a clone of the Hubble Space Telescope, parked in orbit out there around Pluto. Now we can really zoom. And here a key little word comes into play: angular resolution. The angular size of the smallest detail an instrument can reveal. Hubble, as everyone knows, has hawk eyes. With its digital sensor, it can separate details, or pixels, as small as 0.05 arc seconds. Now, Earth is 7,918 miles wide and sits almost 3.7 billion miles off. A quick calculation tells us that from that distance it shows up as a tiny disk, 0.45 arc seconds across. So on Hubble's sensor, the image of Earth would take up exactly 9 pixels. Make that half, since we only ever see half of Earth at a time thanks to the phases. Think about it. A planet with a surface as complex as Earth's captured in an image just 4 or 5 pixels wide. And yet, in that handful of pixels, a sharp Plutonian astronomer who looked carefully would start to pick out quite a few things. The existence of continents, marked by brown and green patches. The oceans, pixels of a deep blue. The polar caps, 2 fixed white zones at the ends. And then the big cloud systems racing along. And here's the most spectacular thing of all: the weather. Because watching Earth day after day, the image would keep changing its face. White pixels born out of nowhere, the cyclones crossing the blue zones and then fizzling out. And that little dance of weather would shout one thing loud and clear: that up there is a living atmosphere, a powerful heat engine, nothing like Mars or the Moon with their still, deserted faces that never change. And then, folks, there's a trick of light that's pure magic. It's called the ocean glint, the mirror-like reflection off water. You know how when you're at the beach at sunset, there's that blinding ribbon of light the sun draws across the water? Well, Earth's oceans do the exact same thing, only fired off towards space. As Earth spins, a little land and a little water take turns passing under the light. Solid ground scatters the light every which way, but water acts like a mirror. And the instant a huge ocean like the Pacific or the Atlantic lands at just the right angle to bounce the sun's rays straight toward Pluto, flash, one of Earth's pixels suddenly lights up, becoming 3 or 4 times brighter than the others, then dims again as the ocean rotates into shadow. And you know what? That's exactly the flash our scientists hunt for today on planets around other stars, to figure out whether they've got liquid water on their surface. From Pluto, that flash would be mathematical proof that Earth is a world covered in sea. And it's not over yet, because there's one last master stroke, and it's even got a gorgeous name: the red edge, the red rim of vegetation. Listen to this one. Plants use the sun's light to live, but they only keep the visible light, the colored kind. All the near-infrared light, they bounce right back like a mirror. They do it so they don't overheat, don't literally cook under the sun. That infrared we can't see with our eyes, but Hubble's instruments sure can. So if our Plutonian astronomers stretch their gaze beyond the rainbow of colors into the infrared, then right at a wavelength of 700 nanometers, they'd see the brightness shoot straight up. A monstrous leap in the graph. And that leap is the signature of chlorophyll, the signature of green life. And to be 100% sure, the scientists on Pluto wouldn't let go of Earth for months. They'd notice the planet makes one full spin every 24 hours, because the continent patches and the ocean flashes come back right on schedule, regular as an alarm clock. And they notice something else incredible, that over the course of a year, that infrared red eagle peak rises and falls. In summer, when the leaves come out in the northern hemisphere, where almost all the land is, the chlorophyll reflection gets really strong. In winter, when the forests shed their leaves or get buried in snow, it collapses. Earth, seen from 3.7 billion miles, would look like it's literally breathing, in time with the seasons. And if, for comparison, they aimed the spectrograph at the moon right next door, nothing. A flat barcode, flat as a board. Just rock, basalt, a rarthosite. Zero atmosphere, zero vapor, zero change. A dead world, geologically and biologically. And all that nothing, by contrast, would make Earth's marvelous strangeness stand out even more. Of course not. The proof of all proofs, the queen of them all, the one that puts a signature under the whole thing, comes from another of astronomers' superpowers, spectroscopy. Hang in there, it's easier than it sounds. Basically, you take the light reflected by the planet and run it through a prism, which spreads it open like a rainbow. Except the gases in the atmosphere don't just sit there quietly. Each molecule, as the light passes through, eats a precise sliver of that rainbow, leaving a black line in its place. And those black lines, all together, form a barcode. A chemical barcode, different for every gas. Impossible to fake. So, our Plutonian scientists aim the spectrograph at Earth's pixels, read the barcode, and what do they find? Loads of water vapor. There is the confirmation that the clouds are water evaporated off the oceans. A healthy dose of carbon dioxide, the gas that works like a blanket and keeps the planet nice and warm, so the water doesn't freeze. And then they find the thing that would make every scientist on Pluto leap out of their chair. An atmosphere stuffed with free oxygen and its protective cousin, ozone. And now pay attention, because here's the whole point. Oxygen is a troublemaker of a gas, a real bully of chemistry. The moment it can, it sticks to everything, rusts iron, reacts with rocks. Leave it alone in an atmosphere and in no time it vanishes, swallowed up by the ground. So finding a planet with 21% free oxygen in its air means one thing only. Up there has to be a giant, tireless source pumping it back into the air every single second, replacing what gets used up. And on Earth, you know what that source is? It's life. It's the plants, the endless forests, the phytoplankton in the oceans, firing oxygen into the air through photosynthesis without ever stopping. It's what astronomers call a deep disequilibrium, an air that on its own simply couldn't exist. And so here it is, the final verdict of Pluto scientists, in black and white, without a shadow of a doubt. With their instruments, they couldn't prove there are cities, cars, roads, people. Too small, too microscopic for their pixels. They know nothing of our history, nothing of the internet, nothing of us. And yet, and get comfy for this one, they'd conclude with absolute rock-solid scientific certainty that this third planet has boundless oceans of liquid water, a complex atmosphere complete with an ozone shield, and a chemistry turned completely upside down, held together by one thing alone, a living, active biosphere. To us, Earth is the obvious backdrop of everyday life, sometimes even a little boring. School, work, traffic, rain. But seen from 3.7 billion miles away through the mirror of a telescope planted in the icy desert of Pluto, our home would officially become stamped, signed, and certified the strangest, most fascinating, most desirable alien planet in the entire universe. And that planet is ours. So that is your whole world shrunk to one living pixel at the edge of the solar system. Now keep pulling back. What would the entire solar system look like to someone staring in from the outside, from the dark between the stars? That's where we go next.